FF4 Euro HPC is the successor to the prior Fortissimo projects. It successfully demonstrates the business benefits of using high-performance computing, artificial intelligence, machine learning, and high-performance data analytics technologies for business in diverse industrial sectors such as manufacturing, healthcare, energy, e-commerce, environment transportation, engineering, and aeronautics. Each productively concluded experiment generates a success story with the intent to inspire HPC uptake in related industrial communities. We are presenting the FF4 Euro HPC success story entitled A High-Fidelity Tool for the Optimal Design of Wind-Assisted Propulsion Technology. The results presented in this success story were produced in collaboration with the Italian National Competence Center. The development of the innovative IT solution in the experiment addressed the needs of the maritime technology manufacturing SME Aero. Aero is a French SME that has created a patented rigid wing technology, Oceanwings, that solves the environmental and economic dilemma facing ship owners, reducing their environmental footprint while remaining competitive and profitable. The Oceanwings consists of a two-element articulated wing sail generating forward thrust through aerodynamic lift. It is controlled by an automated AI-based software that optimizes the wing's angle of attack and camber in real time to maximize thrust and thereby can save up to 45% of a ship's fuel consumption, significantly reducing greenhouse gas emissions.
Aero needed a workflow for fast and reliable evaluation of the aerodynamic characteristics of different combinations of Oceanwings optimized for installation on different ships in order to overcome the limitations of a non-scalable workflow around the commercial simulation software. However, Aero lacked both expertise in the specific numerical simulation tools and the computing resources to run them at the required scale.
Partners developed a robust tool that can be used to automatically launch open foam CFD simulations on HPC systems. This replaced the previously used software with a highly scalable solution and allows thousands of aerodynamics calculations to be performed in a few hours.
This solution makes an affordable tool available to Aero to optimize the Oceanwings design and also to generate large databases with different trimming parameters based on CFD results for various wind conditions to feed its AI-based wing control software.
Improved performance of the AI onboard wing sail control software will lead to higher fuel savings and thereby to follow-up business with existing customers willing to pay for algorithm upgrades. Automation of the design workflow and use of open source code speeds up the development process by a factor of 3 by allowing the running of simultaneous computations without incurring prohibitive license costs. With improved designs and control software, CO2 emissions can be further reduced.
Improved design and thereby aerodynamic performance will make Oceanwings more competitive in terms of price and performance. A 10% increase in performance is possible with these new products, with margins yet to explore for improvements. Furthermore, easier generation of adaptive configurations allows Aero to now make competitive offers for a variety of ships.
The experiment set up an HPC-based automated toolchain and workflow for extensive high-fidelity simulations and optimizations at an affordable cost, with competitive time to solution, providing excellent results which benefit Aero and their technology, Oceanwings. FF4 Euro HPC, SME innovation through HPC. Get inspired. Visit www.ff4eurohpc.eu.